Hello, mathematicians. Today we're going to be learning about systems of linear inequalities. So just a quick review before we get started. Linear inequalities are very similar to linear equations. The only difference is instead of an equal sign, we have an inequality. And instead of just having a line on our graph, we also have a shaded region to represent all solutions to our inequality. When we have linear inequalities, we could have a greater than or less than symbol. And if we do see either one of these, we represent it using a dashed line. And any coordinate on the dashed line is not a solution. However, any coordinate in the shaded region is. And then we have greater than or equal to and less than or equal to. So here we still draw a solid line, and any coordinate on that solid line is a solution to our inequality, and any coordinate in our shaded region is also a solution. So here we have two inequalities. We have y is less than 2x minus 7 and y is greater than or equal to 2x plus 3. So we're going to start off with our first inequality. So y is less than 2x minus 7. And in order to graph that, the first thing we're going to do is we're going to plot the y-intercept. So because it's 2x minus 7, our y-intercept is negative 7. Our slope here is 2, and we could rewrite it as 2 over 1 if it makes it easier. So now from this coordinate, we're going to rise up 2 units, and we're going to go 1 over to the right. And we're going to keep doing that. So we're going to rise up 2 units because our slope is positive, and we're going 1 unit to the right. And because here we have y is less than, our line is going to be dashed. So before we move on, we're going to see which side we should shade. So the easiest coordinate that we could use is 0, 0. Unless the line is on 0, 0, then we have to pick a different coordinate. So y is less than 2x minus 7. And we're going to test out the coordinate 0, 0, so that means we're going to substitute x and y for 0. So 0 is less than 2 times 0 minus 7. So 0 is less than 2 times 0, 0. So 0 minus 7 is just negative 7. So here we end up with 0 is less than negative 7, which is not true. So we're not going to shade the side with 0, 0. We're going to shade the right side because on the right side it does not include the coordinate 0, 0. Now you could also test to see if a coordinate here is true to double check your work. So the second inequality we have is y is greater than or equal to 2x plus 3. And we're also going to start off by plotting our y-intercept. And here our slope is also positive, so we're going to go up 2 over 1 each time as well. So up 2 over 1, up 2 over 1. And we're going to draw our line through these coordinates. And because we have y is greater than or equal to, we're going to draw a solid line. All right, and we're also going to test the coordinate 0, 0 to see if it is a solution to this inequality. So y is less than or equal to 2x plus 3. And we're going to substitute. So 0 is greater than or equal to 2 times 0 plus 3. So 0 is greater than or equal to 0 because 2 times 0 is 0 plus 3. So we end up with 0 is greater than or equal to 3, which is not true. So we're not going to shade underneath this line to the right of it. We're going to shade to the left. And so you'll notice here that these two lines are parallel, and so they don't meet, and both shaded regions are on opposite sides, so they don't have a common region. So there's actually no solution to the system of inequalities, because in the red area, any coordinate here is a solution to our first inequality. Any coordinate in our blue area is a solution to our second inequality, but there's no common area where they meet. So there is no solution to this inequality. All right, so here we have another set of inequalities, and we're going to do the same thing. We're going to graph them. And so we're going to start off with 2x plus 4y is greater than 8. And because this is in standard form, the first thing we need to do to graph this is find our x and our y-intercept. So if we want to find our y-intercept, we're going to substitute x with 0. Two times 0 is 0, so we end up with 4y is greater than 8. Actually, don't need to rewrite that. So we want to get y by itself, so we're going to divide both sides by 4. So we end up with y is greater than 8 divided by 4 is 2. So our y-intercept is 2. So that's where it crosses the y-axis. And now we have to find our x-intercept. And instead of substituting x for 0, we're going to substitute y for 0. And again, 4 times 0 is just 0, so that cancels out. We're left with 2x is greater than 8. And in order to get x by itself, we have to divide both sides by 2. So x is greater than 8 divided by 2 is 4. So our x-intercept is 4. Now that we have the x and the y-intercept, we could draw our line. And because it's greater than, our line is going to be dashed. All right, and so now we're going to test our coordinate, and we could use 0, 0 in this case since our line does not go through the origin. So we're going to substitute x and y for 0. So 2 times 0 is 0, 4 times 0 is 0. So 0 is greater than 8, which we know is not true. So we're not going to shade underneath, we're going to shade above. Okay? All right, and so now we're going to graph x plus 2y is greater than negative 4. All right, and the first thing we're going to do is we're going to find the y-intercept. So we're going to substitute x for 0. So we end up with 2y is greater than negative 4. So divide both sides by 2. And we end up with y is greater than negative 2. So our y-intercept is negative 2. And now to find our x-intercept, we're going to substitute y for 0. So 2 times 0 is just 0, and we end up with x is greater than negative 4. So our x-intercept is negative 4. And because it's greater than, we also have a dashed line. And you'll notice here that these lines are also parallel like our previous lines. And we're going to use the coordinate 0, 0 to see where we should shade. So here we have 0 plus 2 times 0, which is just 0, is greater than negative 4, which is true. So we are going to shade the side with 0, 0. So even though these lines are parallel, they do have a common solution. So everything that was red is also covered by what's blue. So this section here that's blue is only a solution to our second inequality, but this region above that's purple is a solution to both inequalities. So there's no area that just belongs to our first inequality. So everything above the red line is a solution to our first inequality and our second inequality. All right, so here we have two more inequalities, and these two are nice and easy. We have y is greater than 4 and y is less than or equal to negative 2. So our first inequality is greater than 4, so we're going to use a dashed line. And I'm just going to plot that. And if we want to know all the numbers that are greater than, we're going to shade above. And then our second inequality is y is less than or equal to negative 2. So because it's less than or equal to, we're going to use a solid line at -2. And because y is less than or equal to, we're going to shade everything below. And again, here we have two parallel lines that do not have a solution because the areas never intersect. So everything that's in red is a solution to our first inequality, and everything that is in blue is a solution to our second inequality, and there's no area where they meet. So they do not have, so there's no y value that will make both of these inequalities true. There's no solution. Here we have two more inequalities. We have x is less than 3 and x is less than or equal to -1. And so we would graph this as we normally would for linear equations. So x is less than 3 is a vertical line, and because it's less than, we're going to use a dashed line. And we're going to use a dashed line on 3. And because it's less than 3, we're going to shade to the left. And then we have x is less than or equal to -1. And because it's less than or equal to, we're going to use a solid line. And we're going to draw a vertical line at -1. And again, because it's less than or equal to, we're going to shade to the left to include all the numbers that are less than -1. And the solid line already includes it being equal to -1. So we're going to shade to the left. And again, any coordinate in the red area is true for our first inequality. And we could see that this even goes further to the left, but this is also our purple area, which means that anything here is a solution to our first and our second inequality. And anything that is a solution to our second inequality is also a solution to our first inequality. We have two inequalities, and the first one is y is less than -3/2x plus 1, and 3x plus 2y is greater than 2. So we're going to plot the first one as we normally would, starting off with the y-intercept, which is at +1. And then our slope is -3/2. So we're going to go down 3 units, 1, 2, 3. And then we're going to go to the right 2 because the 2 is positive. 1, 2. And then again, we're going to go down 3, 1, 2, 3, and then over 2. And because it's y is less than, we're going to use a dashed line. All right, and then we're going to test out our coordinate 0, 0. So we're going to have y is less than -3/2x plus 1, and we're going to substitute the x and the y for 0. So that gives us 0 is less than. -3/2 times 0 is 0, plus 1 is 1. So 0 is less than 1, and that is true. So we're going to shade on the side that has 0, 0. There we go. And now we're going to plot our next inequality. So because it's in standard form, we're going to find the x and the y-intercept. So 3x plus 2y is greater than 2. And in order to get the y-intercept, we're going to substitute x for 0. So 3 times 0 plus 2y is greater than 2. That cancels out. 2y is greater than 2. In order to get y by itself, we divide both sides by 2, and we end up with y is greater than 1. So our y-intercept is 1. And then we're going to do the same thing, similar. So we're going to do 3x plus 2y. And instead of substituting the x with 0, we're going to substitute the y with 0 to get the x-intercept. So we have 3x, this cancels out because that's 0, is greater than 2. Now in order to get x by itself, we have to divide both sides by 3. And we end up with x is greater than 2 over 3, which is 2/3. So the x-intercept is 2/3. And if you notice that these lines are actually not parallel, they are on the exact same spot, but because they're both dashed line, on the line itself, the solutions are not true for both inequalities because the dashed line tells us that whatever is on the line is not a solution. So let's see what we're going to end up shading. All right, so we're going to use 0, 0. We're going to substitute x and y with 0 and 0. So 3 times 0 is 0, 2 times 0 is 0. So 0 is greater than 2, which is not true. So we're not going to shade on the side with 0, 0. We're going to shade on the opposite side. So here, whatever is in this red area is a solution to our first inequality. Whatever is in the blue area is a solution to our second inequality. And because both of these lines are dashed, there's no coordinate on this line that is a solution for both of these lines. So there is no solution here. And that's it.